Hello ladies and gentlemen, boys and girls. My name is Mr. Do and science is my business. But welcome to Mr. Do Scienceworld, and today we're going to talk about projectile motion in 2 dimensions. So we're going to look at 2D. The last time we looked at what? The 1D. Today we want to look at 2D. Right. Let's begin by looking at what a projectile is. Again here. An object in motion through space is what we refer to as what? A projectile. So you can have anything like such objects that are being displayed on the screen right now, right? So these are all what referred to as a projectile because they are all undergoing motion in space. Now let's look at some examples of a projectile motions. Right. An object that is dropped from rest is a projectile. So if I have any object and I'm dropping the object from a certain height to the ground, the object is said to be what? A projectile. Provided that the influence of air resistance is what? Is negligible. Okay. So if I have, as displayed here, I'm dropping an object in this instance, we will say that this object is what? Is a projectile. Let's look at another. An object that is thrown vertically upward is also what? A projectile. So, provided that the influence of air resistance again is also what? Is also negligible. So if you throw it upwards or you are dropping it, as long as there is no influence of air resistance, we say that the object is what? Is a projectile. Right, so look at this scenario as well. Now let's move ahead and see an object which is thrown upward at an angle to the horizontal is also a projectile, provided that the influence of air resistance is also what? Negligible. When you look at the 2 scenarios that I looked at in the first place, the first one, the object was being dropped. The second one, the object is being thrown vertically upward. And now the another object is being thrown upward, but this time around it is being thrown at what? At an angle to the horizontal grounds. Right. And there is a reason why this is being thrown what? At an angle. So let's see. Let's draw a free body diagram of a projectile as it is what? Falling with air resistance. If there is a projectile and it is falling with an air resistance, how does the free body diagram looks like? Remember, in our first video there we spoke about that which we call the terminal velocity, and that's exactly what we're going to still experience here. So we can see that there was a force, okay, from the air resistance, and there is also what? The force of what? Gravity here. These 2 forces are acting on the what? On the object, and therefore that is the free body diagram for this particular what? Object which is falling with air resistance. Okay, let's try and look at this cannon that we have here and see what happens. Right, if just dropped from rest, so if you have this cannon there and the ball is just being dropped from rest in the presence of a gravity, the cannonball would accelerate downwards, gaining speed at a rate of 9.8 meters per second every second. So here the object is now being dropped by the cannon, okay, or the ball is being dropped by the cannon, and because it is doing this under the influence of gravity, the object is accelerating at a constant what? At a constant speed. This is consistent with our what? Our concept of what? Free fall. Object accelerating at what? At a rate we call the acceleration of what? Acceleration of gravity, or the gravitational acceleration. Now let's look at this again. In the absence of gravity, the cannonball will continue its horizontal motion at what? At a constant velocity, if we neglect the what? The air resistance. So if you decide to say, okay, now it is not falling under the influence of gravity. First, it was falling under the influence of gravity, and then it fell what? Horizontally. So we have what? Sorry, vertically. So we have what? The vertical what? Motion only taking place. Right. Gravity free path. On the other side is where we are looking at it from the point where it is happening in the absence of what? Gravity. So, and that will also be consistent with what? Our concept of what? The law of what? Inertia. If we have it like this, let's try and see what we're going to see and get a graph for this and see how the graph is going to look like. So we will see this is going to form at each point where the ball is what? Is moving, its distance. If we try to form what? An axis to that and draw a graph, this is how our graph is going to look like. We have a graph that looks exactly like this. Now, let's analyze this graph that we are seeing, because the object is undergoing what? A projectile motion now. The graph that we have is a projectile motion, and now we want to analyze that graph. Therefore, if we project the cannonball horizontally in the presence of gravity, then the cannonball will maintain the same horizontal motion as before, a constant horizontal velocity, whilst the force of gravity will act upon the what? The cannonball to cause the same vertical motion as before, a downward acceleration, and this will result in what? In a projectile motions. Now we have gotten to understand the concepts behind this. At each point where the object is moving or the object is falling, we can see that when it was on the horizontal ground, at the first instance when the ball was released from the cannon, we can see that there is a horizontal component and there is a vertical component of that ball, because they are experiencing what? This velocity that is coming. The velocity has two components, the x component and the what? And the y component. But look at one interesting thing. The x component started with what? A higher value. So the velocity on the horizontal side is greater than the velocity on the what? On the vertical side. At the second point there, we can see that the velocity on the x-axis is still greater than the velocity on the y-axis, but this time around the y has increased a little. And it will continue like that until we will see that we'll reach a point where the vertical component will be greater than what? The horizontal component. Now, let us try and summarize all that we have just said about a projectile. A projectile is any object upon which the only force acting is the what? Is a gravity. And projectiles travel with a parabolic trajectory due to the what? The influence of gravity. There are no horizontal forces acting upon projectiles, and thus no horizontal acceleration. The horizontal velocity of a projectile is constant. Take note of that. The horizontal velocity of a projectile is what? Is constant, never changing in value. There is a vertical acceleration caused by the gravity, and the vertical velocity of a projectile changes by 9.8 meters per second each second. So it means that if the vertical start with 9.80 meters per second, on the second part it moves straight away to 19.60 meters per second. So it keeps increasing per second interval of time. The horizontal motion of a projectile is dependent of its word vertical motion that we can see based on the above statement. So let's try and see something here. Now suppose that our cannon is aimed upwards and shot at an angle to the horizontal from the same cliff that we were given. Draw the path of the cannonball as it is what? Affected by gravity. Remember the first one, the ball was just being dropped. But see the second part now. Now it is being tilted at a certain angle and now is being fired on. So what do we see? We will see the trajectory being like this. A parabola of this form will be formed. And let's try and analyze this parabola now, or this parabolic shape. Okay, we can see now that we're still trying to find the what? The components. There is a vertical component and there is what? A horizontal component as well. And you can see what is happening, that the horizontal component, we have said earlier that it is constant, so it does not change. It remains the same. From the initial state where the ball was fired from the cannon, it was fired with a greater velocity. And we can see that the velocity, so at point 1, the velocity is greater than point 2. Which means that as it is moving vertically, the velocity is what? Is decreasing. It got to the third point there is no vertical component there. Why? Because the vertical component, the velocity for that is what? Is 0. Why? The object has reached its maximum height and therefore is having a momentary stop. So the velocity, final velocity on that part, on the vertical section is what? Is 0. Now it tries to descend, and as it is descending, you can see that the vertical component velocity is what? Is increasing. So this tells you that whenever that you throw an object up, as the object is going up, its velocity on the vertical component decreases. And when it is descending, its what? Velocity decreases. Alright, let's look at some examples here and see. Write down 4 kinematic equations for a constant acceleration. We want to write 4 kinematic equations for a constant acceleration. So we are having a constant acceleration. That is the important thing here. Equation number 1 that we're going to have is, say V final is equals to VI plus 80. 2. V final squared is equals to V initial squared plus 2AD. It could be 2AS or whatever way that you use it. It is just a variable and it can change. Okay, now let's see. The third one is the vector component. Okay, of the velocity is now equals to the what? The sum of the what? Of the velocities divided by 2. So we are taking just the average what? Velocity. So that is the second equation, the average velocity. And the last equation we can have is the what? Is where we are looking at the displacement being equals to the velocity multiplied by the time plus half AT squared. Now let's see. Let's write down the kinematic equation for a constant acceleration in 2 dimensions also and see. In 2 dimensions, for the horizontal component, we can have what Vx is equals to Vix plus Axt. Please, if you see V naught, it still stands for initial velocity. If you see V, in this case here, stands for the final velocity, which you can still use what? Your Vf. Right. 2, we have Vx squared is equals to V naught x squared plus 2ax dx. And we have what? The average of the x component as well. And then we can have the displacement also. And when we go into the vertical component part, these are also the equations that we can have there. So these are the kinematic equations for a constant acceleration in 2 dimensions. Let's try and see to resolve a projectile velocity into a horizontal and a vertical component. Here we need the knowledge of mathematics to do this, and the aspect of maths we're going to make use of is the what? Is the trigonometry, where we're going to make use of our SOHCAHTOA in dealing with solving problems like this. So one of the initial steps of solving a projectile motion problem is to determine the components of the what? Of the initial velocity. So let's try this. Consider a projectile launched with an initial velocity of 50 meters per second at an angle of 60 degrees above the horizontal. Now the question is, determine the components of the initial velocity. Also determine the components of the velocity after 1.0 seconds. Finally, you will determine the magnitude of the what? Of the velocity of the projectile after 1.0 seconds. Now remember, velocity is a vector quantity, therefore has magnitude and at the same time got what? Direction. So but if you are told by the question as we have here, determine the magnitude, which means the direction is not important here. Alright, so let's look at the initial components. This is what we will have. So this is what we are given, and that is going to be our 50 meters, which was what? Inclined at an angle of 60 degrees. So the components that we are going to have are going to be like this. We have the Vy and then the Vx, which we need to determine. What do I need to do? I need to form what? A triangle to this. So that once that is done, I'll be able to calculate for what? My x component, and calculate for my y component of the what? Of the velocity. Remember that the magnitude of the initial velocity is what? Is 50 meters per second. So if I find the x component by this, remember we're going to have this as the what? As the adjacent to that, so that become cos. So which means that Vxi is equals to V cos theta. What is the theta? Theta is 60 degrees. So that becomes what? 50 cos 60 degrees. And that is going to give us what? 25 meters per second. Which means that the what? The part of the what? Of the velocity which the object is going to use in moving in the x component is what? Is 25 meters per second. That is the velocity with which the object will be moving in the x component. Let's find on the y component. On the y component, I know immediately we calculated this and got 25. Somebody will say, okay, oh, then it means that the other part is also 25. That's not true. That's not true. Mathematically, it's not. Alright, because this is vectors. So therefore, what do? We will look at it from this point and say Vyi is equals to what? V sine theta. And then you do the substitution. And once you calculate this, we are getting what? 43 meters per second. I know somebody will ask the question, if we add 25 meters per second to 43 meters per second, it is not going to give us 50 meters per second. So why? Well, the 50 meters per second is the resultant for the x and the y components. Therefore, if you resolve these 43 meters per second and 25 meters per second, we'll still get back the 50 meters per second. Right. Let's solve the other part of the question, because this is the first part which says we should determine the component of the initial velocity. Now let's go to the part that says we should determine the component of the velocity after 1 second. Right. If you look at it, this is our initial component. Then after 1 second, what is going to happen? The 1 second, we will see that the horizontal component is just going to be the vector that we have there, and we are going to have two components for the vertical one in the downward direction and the other in the vertical direction. So we need to find the vector sum of these before we'll be able to find a resultant. Okay, so if we do that, straight away we can say that the Vy at 1 second is just going to be what? It's going to be the Vyi plus what? The Vyg, where we dealing with the gravitational part of the vector. Okay, right. So here our Vyg is just simply what? 80, and we will just do that calculation straight away and do the substitutions there, and we'll find that to become what? Negative 9.80 meters per second. Now we need to go back and substitute that into finding the final Vy. Final Vy is now the sum of these two components. So therefore, if you add the two together, we are going to have that to become 33.501 meters per second. Right? If you leave it in the correct sigfic, we are having 34 meters per second. Now, that becomes the velocity after what? After the 1 second. Okay. Let's try and go to the last part, where we're told by the question that we should determine the magnitude of the velocity of the projectile after the 1 second. Now we want to find the magnitude. Finding the magnitude there is like we are looking for the resultant of the x component and the y component after 1 second. So once I do that, then we expect that it's forming a vector like this to give us a right angle triangle. Remember, we're not going to solve for theta because we need only the magnitude. We don't need the direction, so we're not going to solve for that. Right. So once I do this, let's find the V1, which is the resultant. The red arrow is representing the resultant. So we're going to solve for that. And if we do that by mathematical substitution, where we are going to apply the Pythagoras theorem. So if you apply the Pythagoras theorem, we solve that and we're getting our answer to become 42 meters per second. That becomes the magnitude. If we were told to find the direction, then it means we have to determine theta, which we can use any of the two components to solve for that. But now we're told to find only the magnitude. So that is 42 meters per second. Right. The point of resolving an initial velocity vector into each two component is to use the values of these two components to determine such parameters as the horizontal displacement, the vertical displacement, the final vertical velocity, the times to reach the peak or the maximum height of the trajectory, and then the time to fall to the ground. Thank you very much for watching this video, and if you have not subscribed to our YouTube channel, please don't forget subscribe to this YouTube channel. As you subscribe, click on the notification bell so that every time we release any new video, you'll be the first person to watch it. And as you click on the bell, please give your comment, and then share for others to also see. And as we do that, your comment is very important to us. So please do give comments, as we appreciate what you are doing for us. Well, we will say that you have to keep on learning. For learning is life, and life is learning. We'll see you once again when we come to the calculations for what? 2-dimension. We'll be dealing with pure questions or problem solving on 2-dimension projectiles. Thank you. See you next time. Bye-bye.